Hi everyone, this is my third video on abstract algebra. I am going to talk about general linear group in this video. Right, so let's find out what is general linear group. So GLN R. So this is set of n by n matrices such that its determinant is not equal to 0. Or you can state this in simple terms in this manner. So you can say GLNR is the set of all n by n invertible matrices. Right. So let's try to prove that this is a group. So what is the first property that should satisfy to be a group? So first thing that you need to identify is this is a set, right? So then we should define a binary operation on this set. So let's say star is a binary operation. Binary operation, and let A and B are in GLNR. Then I will define this binary operation in this manner. A star B equals AB. So this binary operation would be usual matrix multiplication. I think that is clear for you. So in this case, binary operation is usual matrix multiplication. So let's find out why this is a binary operation. So what can you say about? So if this is a binary operation, this also should belong to GLNR. We need to find out whether this is correct or not. So what can you tell about det AB? That is equal to det A into det B. And we already know that A and B belongs to GLNR. Therefore, this is not equal to 0. So I can say that AB belongs to GLNR, and this implies me A star B belongs to GLNR. So hence you can say that this is a binary operation. So this is a binary operation. So that is done. So let's move into the first property. First property is, as I discussed in my previous video, first property would be the associativity. Right. So we need to prove that A star B star C is equal to A star B star C. So let's prove this. So what is A star B star C? In this case, star is usual matrix multiplication, then therefore you can write this in this form. And since this is matrix multiplication, you can write this in this form. And this would be equal to A star B star C. So this group is associative, that is clear. Let's move into proof that this group is the existence of identity. So what is identity? So let's say E is the identity of this group. So if E is the identity, what should be happened if you do the star operation between A and E, you should end up at A. So according to my definition, this can be written as A into E equals A. And what will happen if I multiply both sides by A inverse? Since A is invertible, I can do this. Since A belongs to GLNR, I can do this operation, right? So this is I, and I into E equals to, and identity element is the identity matrix. So E is by an identity matrix. I think that part is clear for you. So let's find out what is the inverse. Let find the inverse. So let's say B is the inverse of A. So if B is the inverse of A, what should happen if you do star operation between A and B? Then you should end up at the identity element. And since the star is usual matrix multiplication, I can write this in this form, and this is identity. Now I already know that A is belong to GLNR. Therefore I can do this operation. So A inverse into A is equal to I, and I into B equals A inverse, and B is going to be equal to A inverse. So what is the inverse of this matrix? That is A inverse, and it is the inverse in this group. So for every A in GLNR, its inverse, A inverse is the inverse of matrix A. So now we can conclude that this is a group. I think this proof is clear for all of you. So this is very important when we are going to talk about linear transformations, especially when we are talking about rotations around the axis. This is very essential concept. So I am going to stop my video from this point. In my next video, I hope to solve some problems regarding the concepts that I have already discussed. And if you think my video, if you get anything from my video, please put a comment in the comment section, and please share this video among your friends who are interested in learning mathematics and who enjoy learning maths. Thank you for watching.